Okay, so what we've found out based on that video is this whole idea that velocity involves direction and speed doesn't. It's just a magnitude. And so that leads us kind of to this important distinction. There in physics are what are called scalar quantities and vector quantities. Scalar and vector quantities. And so let's just kind of make sure we understand the difference between these. So I'm going to start with a little definition for you. So when you stand on a scale, you find out that you are a certain mass. That's a scalar quantity. So scalar simply means an amount. It means a number. So scalar just means an amount. Some sort of number. So let's look at some examples. Well, mass is scalar. Okay, you stand on a scale and you find out you're 80 kilograms or something like that. Temperature. Temperature is a scalar quantity. It's 18 degrees Celsius out. It's just a number. Okay, so degrees Celsius would be considered. Okay. What other kinds of things might be considered? Money. Yeah, just okay. You just have a number like money. In what we've been talking about right now, speed. Speed is scalar. Distance. Distance is scalar. So speed like so many meters per second. Distance like so many meters. Those are simply all scalar quantities. Time. Time is scalar. So many seconds. So scalar is just about quantity. It's just about a number. What is vector? Well, vector is a little bit different. Vector quantities include amount and direction. So when you start adding directions to things, now we're talking about vector quantities, which is why we use an arrow to show vector quantities, because an arrow shows direction. And so if you remember that formula for velocity, they had little arrows over top of things. Well, now you know you're working with a vector quantity. So let's look at some examples. Well, velocity is considered to be vector. So we say so many meters per second east. Okay, we put that direction there. That becomes a vector quantity. Displacement, which we'll talk about in just a minute, is a vector quantity. Acceleration, which we'll talk about a little bit later this week, is a vector quantity. And so directions are attached to vector quantities. Okay, so that's kind of the big difference between those two things. Okay, so what we have in front of us now is a graph, and we're going to just spend a couple of minutes learning how to graph vector quantities. There's actually two ways to do that. There's what's called a x-axis method and a navigator method. And people get these confused all the time. I'll tell you right now, the x-axis method is the new one for you. The navigator method, you're going to realize right away, is actually your compass system. So if you've worked with compasses before, there's nothing really new there. You'll just use your compass directions to kind of work with that. So the x-axis method kind of graphs things like this. You have your grid here, and you can see that your x-axis, which is this horizontal line here, that is the beginning of your graph. That's where you're going to start graphing from. So the x-axis is equal to 0 degrees. And when you graph using this method, your degrees go around in a counterclockwise method. So that's where I'm going to just put a little check mark right there. You start at the x and work counterclockwise. And then the other thing to remember in this method is directions that are up and to the right are considered to be positive directions, and if they go to the left or down, they're negative directions. So if you take a look on your textbook, page 139, you see the kind of beige example problem B14. You all have that in front of you. How would you graph a vector that represents 6 meters at 30 degrees? How would you graph that? Well, the first thing you would have to do, I'm not going to actually do that on my graph, is you would have to decide on a certain distance to represent on your graph to represent a certain number of meters. So you might say, when I draw a line, every centimeter of the line that I draw is going to represent a meter. That would make some good sense. So maybe when you draw yours, you can say that a meter represented by 1 centimeter on your graph. So we're going to try and draw a vector for 6 meters at 30 degrees. So how would you do that? Well, the first thing you would do is you would go and you would grab your protractor. I think it just came up here, so let me kind of bring that down there a second. Okay, so you would grab your protractor and you would set it right on the x-axis like that. Now we're looking for a 30-degree line, a 30-degree mark. And if you remember the x-axis, you start at 0 and you work counterclockwise. And so what you would simply do then is you would take your pencil, you would find the 30-degree mark. Oops, looks like my smart board's out just a little bit. Let me get rid of that one. Okay, so you'd take your line and you would run it at about 30 degrees. Okay, so there is my, using the x-axis method, there is my 30-degree line. Okay, what about another one? Well, it says vector B is 10 meters to the right. Well, what's to the right? Well, that would simply be right on the x-axis. And so I would take, maybe I'll pick a different color, like my green one here, and I would, there's 10 meters. And of course, it would be a longer line than my 6-meter line, so that would be 10 meters to the right. So there's vector B. How about negative 8 meters down? What would that one look like? I'll take this blue one here. And down is negative, and it would just run right down on that y-axis, but in a negative direction. And that's supposed to represent a negative 8 meters. Why is it negative? Because it's down. And remember, in this method, up and to the right are positive. So when we use, so anything down is negative. As soon as we go down, like in this case, it's negative. And then the last one is 2 meters at 230 degrees. And so that one becomes a wee little bit more tricky. Okay, so I'd have to think about, well, where is 230 degrees? So I know that this spot on my graph is 0. So that's 90. So that's 180, and I need 230. So what I would do then is I would take my protractor and I would swing it this way, and so that I need to add, how many more degrees do I need to add to make that 230? So good. So I'd go 180 and 50 is 230. So then I would find my 50-degree mark off of this axis right here, which is actually the 40-degree mark. So I need to bring it right in about there. And so I would take my pen and I would run it right in there. Okay? And so now I've put all of my markings in there, and I would be good. So this is 50 degrees right in here. All right. I'm going to ask you to try one. I'm going to ask you to put one in. Could you put the 2 meter per second line in at 135 degrees, please? Okay, so the question is, where would we put the number the line, the vector 135 in here? So 2 meters at 135. So again, we know that we start always at 0 right on the x-axis. So 90 would be that y-axis, and then we would keep on going, right? So 100, 110, 120, 130, we needed 135. So that's going to put us right about there. And then I can grab my pen and I can run that 135 in there, something like that. And of course, that's a little bit of a long line. It should be a real short line because it only represents 2 meters. Okay, so there you have put in 5 different vectors, or grafted 5 different vectors using the x-axis method. All right, the other method that you can use is the navigator method, and this is just like your compass work. There's really nothing extra special about this one. And here's the good news: when we do our physics problems, we just about always use the navigator method for velocities. So east and west, north and south. So the thing that you have to know about this is that the 0 degree mark in this method starts on the y-axis, just like you would on a compass, right? Up is north, and this is our 0 mark. And then we go in a clockwise method around the kind of the grid or the graph that way. Here's a couple of things to make some note of. So we work clockwise in this one, not counterclockwise. And north and east are positive directions. South and west are negative directions. That's probably the thing I would put a star beside, because that is by far the most important thing for you to remember. Because when we start calculating velocities, we need to know which directions are positive and which directions are negative. So what I'm going to get you to do in your textbook, page 140, I'll get you to take your protractor, put vectors A, B, C, and D in, and then I'd like you to do practice problem 7, which is the 135 degree mark. We'll see how you do in just a couple of minutes.